campus selections which has program requirements, or they're really confused what to learn as an electronic engineer, or is really programming necessary for an electronics engineer. So yeah, I would like to talk about this particular topic today, about is really programming necessary for an electronic graduate, and if so, which programming language is necessary, or what you should know, or is it really necessary to know? So yeah, and just a second. So today's agenda will be just the introduction, which is already given by Prabhat Imam about me, so I wouldn't be repeating it again. And I would be talking about is programming really necessary, and if so, which field of electronics requires programming. And after knowing that, what's next, what you should do? Do you really have to learn a programming language, or how much do you have to know? And in the end, we should see what we can conclude in today's talk. So I wouldn't repeat again the introduction, I would just skip it. So the main topic is, as I said, is programming really necessary for an electronic engineer? If you ask me this question, I would just say yes, it's a big yes, and a small maybe. And if you can see that there's a no anywhere in the screen. So before I actually continue talking on this, I would like to ask if I'm audible, or if I have to increase my volume, or is it fine?
Yeah, I think it's fine, but you can be a little more audible. The volume is a little low.
Okay.
Hi, Dinakar, please put your entire energy to speak. It's really
sure.
But the volume should not go low.
Yeah, sure. I'll try to be as loud as possible.
Yes, thank you.
Okay. So as you can see in the screen, if you are
Dinakar, just give me a moment. Yes. Dinakar, are you able to hear me? Yes. Dinakar, can you hear us?
Yes, ma'am, I can hear you.
Sorry about that. Yeah, please go ahead.
Yeah. Thank you. So why a big S and why a small maybe? So if you ask me why it is so, I would say knowing a programming language basically depends on which field you want to concentrate your field of study or research or work after your bachelor's. The main reason is that we need to understand that bachelor's education or the university education is just to introduce you to different fields that exist in a particular field of science or engineering. It doesn't stop you from learning. It's just the beginning. You just need to understand that the university education or any education, be it in your life, it's just the beginning for you to learn more. So you're just introduced to certain topics, and you're not just curtailed from not learning anything more. So it's up to you. So you might have studied, or in 2 years of your bachelor's experience or 3 years of your bachelor's experience, by now you might have come across several fields of electronics, like analog electronics, digital electronics, signal processing, or embedded processing, or anything as such. You have different fields, and you might have asked yourself a question some point in time that, why am I learning all of these? Like, should I learn everything, or should I just concentrate on one particular field? So all you need to know is that the university is just for you to know that there is something out there, and it just introduces you to something new. It's not letting you to be a proficient, engineer in particular field. It's up to you to be one. You can choose your own field, and depending on that, it depends if you want to learn a programming language, or if it is necessary for you to know something, or if it is not necessary. So let's get into it detail, like in the next slides. But I would say a big yes. Even if there is some fields of electronics where knowing the programming language is not really necessary, but it is it's slightly necessary. It's a slight maybe. The reason is, if you can see, the world is moving towards automation. Like the industry wants the computers or the machines to do all the job as much as possible and try to reduce the human intervention, because wherever there is human intervention in design or innovation or technology, there is certain amount of error that is introduced into the design cycle. And industry wants to reduce this error as much as possible, because in the end, industry just wants high productivity of the product that they're designing. So they want everything to be automated. So rather than letting an engineer to power up a system, to write a code every time, to compile a code every time, and then execute it on a processor, the industry just wants the engineer to automate the process and do all the procedures just by executing a Python script, for example. You just run / something, and then the computer, the program handles everything for you. Like, you just have to sit and then run the code and then wait for it to produce some output. So yes, programming is necessary. And also the other reason is that you know that you aren't the only engineer that is being graduated every year. There are like thousands of engineers in our country and several countries across the world that are being graduated every year. So it's not every engineer would just rely on something that is being taught at the university. There are also people who learn something on their own, and they try to be something better than you. They try to improve their skill sets by learning something on their own. And industry wants to invest their money on someone who already has some knowledge, some background knowledge in some particular field. So just imagine you being an engineer, just learns what is being taught in the university and doesn't know something else extra, like writing a C program or writing a Python automated script. Of course, the industry will prefer someone who knows more than you, right? Like, why would an industry invest money in teaching you everything from the scratch and then trying to make you as their employee? They would, of course, hire someone who already has this knowledge, so they can save their time and their money and their effort. So the industry prefers enthusiastic engineers who learn things on their own and have extra knowledge over the traditional graduates. And yeah, it's up to you. You need to be prepared for the future. You don't know what happens in the industry next, because electronics is a field where innovation happens every day. A new product comes out every day. Like, you just can't sit and wait for like 15 years for something new to come. No, every day there is some new innovation. So you need to be prepared for the future. So it's up to you. And if programming is necessary, then you might ask, which field of electronics does, it requires programming? Is it analog electronics, or is it digital electronics, or is it both analog and digital? To answer this question, I would like to explain this particular figure which I found online, which is like really interesting, which explains different field of electronics and where exactly the programming is required and which you can actually choose, or what is your field of interest, and then decide whether or not for you to continue in that particular field. So you need to understand that you weren't taught electronics, or you weren't taught physics or chemistry or biology all of a sudden in your first grade or second grade. You were first introduced to basic math by adding and subtracting, multiplying, and then you were introduced to science as a subject, and then it was further bifurcated as physics, chemistry, electronics. Just like how you learn alphabets and then you join the alphabets to learn the words, and then you learn sentences, and then you start speaking, right? Not all of a sudden you are taught how to speak a new language. You are first taught how to pronounce an alphabet, how to spell an alphabet, and then spell a word, and then start talking the entire language. The same way, the entire engineering is based on maths and physics. And even in your first and second year of engineering, you might have had engineering mathematics, and you might be wondering why exactly you're learning differential equations or partial differential equations, and you might be thinking, like, am I really going to use this in real life? The answer is, if it wasn't really necessary, there wouldn't have been an invention or discovery of anything in this world. It's only because there was a need for something in this world that people worked towards it and then brought the concept into existence, and you are being taught. And for example, you might think, why are you even learning differential partial equations? But if you have seen in field theory in your third semester, you might be using the Maxwell's equations or any other equation in microwave engineering or radars and systems. You will be using these partial derivatives, integrals, calculus everywhere. It's just for you to, it's just for you to make the subjects and concepts easier to understand, that mathematics or physics is introduced in earlier classes. So from your third semester, you would be introduced to basic electronic circuits, or also I guess people would have learned it in their pre-university and your first semesters, you would be introduced to basic circuits like resistors, transistors, and inductors, and current equations and derivatives and stuff. And after that, you are, further taught into in detail about what analog electronics is, what digital electronics is. So these are the two main fields that I could say that electronics is further classified into. And in analog electronics, you would learn about diodes, transistors, and op amps and stuff. And then you would, in digital electronics, you would learn about basic gates, OR gate, AND gate, NOT gate, XOR, XNOT, whatnot, like NAND, NOR, universal gates and stuff. And then if you continue studying more in digital electronics, then after your gates, you would be taught how to design a multiplexer, how to design a flip-flop, a register, and after that, you were also taught how to design a processor. Like, for example, once you're taught flip-flops and stuff, you will also be introduced to something called hardware description languages. Like for you to code, you have Verilog labs and PhD labs in your third or fourth semester. And if you see, you're already introduced to programming in your engineering life. Like you already know a programming language, but this is not a high-level software programming language, but this is something related to hardware, where you write you define signals, you define a wire, you define registers, and then you define OR gate, AND gate, and you write an assembly code. You already know something in programming. So it's not that being an electronic engineer, there is no need that you shouldn't know any programming. You already know something. If you concentrate or if you continue your work or research or study further in digital electronics, you will be coding a lot of things in VHDL and Verilog. You will be designing your own processor. You will be designing everything in VHDL and Verilog. And if you further develop your interest in the same field, rather than restricting yourself to writing, a VHDL Verilog code, you will also be writing something in C language, which is more abstract. Like, writing a machine code was not everybody's cup of tea, so they came up with assembly code for particular architecture. And writing an assembly code is also not everybody's cup of tea. To make life simpler, people came up with programming languages like C language. And yeah, and you also write C programs to design something that should work on a hardware. So it's also related to electronics. You also need to understand that computer science came into existence just because of the innovations and inventions in the field of electronics, like transistors and integrated circuits after that. If that hadn't happened in 1947 in Bell Labs, I don't think computers would have existed today, and I don't think we would have had a video call today now explaining about if programming is necessary or not. So it's because of electronics that software came into existence, computer systems came into existence, and software came into existence. So you also write programs in C language if you are trying to program something or trying to write, trying to design some software, or trying to design a software for a hardware. For example, when you're designing a laptop or when you have a microprocessor, you might have had microcontrollers and microprocessors in your third and fourth semester, where you would have written assembly codes as well as you would have written embedded C code. So if you see, there is a C code embedded, which is somewhat related to hardware and software. So it is necessary if you concentrate a lot in digital electronics, and if you dive deep into the field of digital electronics, you need assembly language. If you're not comfortable with assembly, you can go one abstraction level higher and then start writing the codes in VHDL Verilog, and another abstraction level higher, you can start writing your codes in C program. And the compiler will then do the work for you to convert it into assembly code and then in the end an executable file. So it's up to your convenience and your field of interest that you can choose which particular sector you want to work in, and if you really want to learn a new language or not. But it's always better if you know something extra, because in the end you would know what is exactly happening on a software level, and you could also understand what exactly the software is doing on your hardware. So being an electronic engineer is such a great thing, because you really know what is happening when you're doing something. Like if you go and ask a computer science scientist, like a computer engineer, a software engineer, he wouldn't know what exactly would be happening in a microprocessor in a deep level, but you being an electronic engineer would know what exactly a software code, what exactly printf is doing,